Dear students, welcome. We are solving problems on the innate differentiation. Today, it is our 7th lecture on this chapter. Let us try to solve some more problems. Example 1. Show that the nth differentiation, nth differential coefficient of x cube divided by x square minus 1 for x is equal to 0. For x is equal to 0. Nth differential coefficient of this for x is equal to 0 is 0 when n is even and is minus factorial n when n is odd and greater than 1. Odd and greater than 1. You see, we have to find the nth differentiation of this. First, we have to find the nth differentiation of x cube divided by x square minus 1. Then, for x is equal to 0, what will be the value of the nth differentiation? Next, we check two conditions. When n is even, then all the nth differentiation for x is equal to 0 will be equal to 0. And when n is odd, then it is minus factorial n. Let us try to solve this problem. Solution. Let y equal to x cube divided by x square minus 1. This can be written as x cube minus x plus x divided by x square minus 1. This is equal to x into x square minus 1 divided by x square minus 1 plus x divided by x square minus 1. This means this is equal to x plus x divided by x plus 1 into x minus 1. This is equal to x plus 1 by 2 1 by x minus 1 plus 1 by x plus 1. Suppose this is number 1. Y is equal to this. We have got this. Now, notice that n is greater than 1 and greater than, n is odd and greater than 1. The value of n may be the even number. When n is even, then the value of n will be 2, 4, 6, 8, 10 like this. And when n is odd, the value of n is 3, 5, 7, 9 like that. It is not 1. It is greater than 1. It is greater than 1. Now notice that if you differentiate 1, then for this term you will get 1. And you differentiate it second times, then for this term the differentiation will be equal to 0. Therefore, for n is greater than 1, the contribution from this term, there will be no contribution for this term. Contribution from this term is equal to 0. There is no term from this contribution. So from this term x. Now differentiating n times. Differentiating n times, we get. Differentiating 1 n times, we get ym. This is equal to, for this term we will get 0 because n is greater than 1. Half of, For this term, you will get minus 1 whole to the power n factorial n divided by x minus 1 whole to the power n plus 1 plus minus 1 whole to the power n factorial n divided by x plus 1 whole to the power n plus 1. You will get this. Or yn you will get half into minus 1 whole to the power n factorial n into 1 by x minus 1 whole to the power n plus 1 plus 1 by x plus 1 whole to the power n plus 1 whole to the power n plus 1. Now I am writing here yn 0 for n is equal to, for x is equal to 0. Now for x is equal to 0, for x is equal to 0, yn 0, suppose this is number 2, this is number 2, put x is equal to 0 into 2 implies yn 0, this is equal to half into minus 1 whole to the power n factorial n 1 by minus 1 whole to the power n plus 1 plus this is equal to 1, because if you put x is equal to 0 1 to the power n plus 1, this term will be equal to 1. Suppose this is number 3, this is number 3. Now case 1, when n is even, when n is even, case 1, when n is even, then minus 1 whole to the power n, this is equal to, obviously this is equal to 1, minus 1 whole to the power 1, this is equal to 1, minus 1 whole to the power n plus 1, this is equal to minus 1, you will get this is equal to minus 1. Therefore from 3 you will get, therefore from 3 you will get, therefore 3 implies, in this case, therefore from 3 you will get yn 0, this is equal to half, it will be 1 into factorial n into minus 1 plus 1, this is equal to 0, this is equal to 0. When n is, it is n is even, then yn 0, this is equal to 0. Case 2, when n is odd, when n is odd, then when n is odd, then minus 1 whole to the power n, it will be equal to minus 1, minus 1 whole to the power n plus 1, n plus 1 will be even, then this is equal to 1, therefore 3 implies yn 0, this is equal to half into, it will be minus 1 factorial n, it will be 1 plus 1, 1 plus 1, this is equal to minus half factorial n into 2, this is equal to minus factorial n. When n is odd, we have obtained yn 0 equal to minus n, minus factorial n. When n is even, it is 0. Therefore, you understand, I think so. Now, let us take another example. Example terms. So that the value when x equal to 0 of d to the power n tan inverse x, so that the value when x is equal to 0 of the nth differentiation of man is 0 factorial n minus 1 or minus factorial n minus 1 according as n is of the form twice p 4p plus 1 or 4p plus 3 respectively. 4p plus 3 respectively. Notice that we have to find the nth differentiation of tan inverse x, which has been already done. Next, we have to find the nth differentiation of tan inverse x for x is equal to 0. Next, we have to discuss three conditions. Number condition 1, if n is of the form twice p, then we have to show that the nth differentiation for x is equal to 0 is 0. Next, we have to find the condition when n is equal to 4p plus 1. Then we have to show that the nth differentiation when x is equal to 0, for x is equal to 0, in this case is factorial n minus 1. And when n is of the form 4p plus 3, then it is of the form, then the nth differentiation will be minus factorial n minus 1. Minus factorial n minus 1. Solution. Let us try to solve this problem. Let y this is equal to tan inverse x. Let y this is equal to tan inverse x. This means y1 means we are differentiating tan inverse x. y1 this is equal to 1 by 1 plus x square. This means y1 this is equal to 1 by x plus I into x minus I. 1 by x plus I into x minus I. Now, this means y1 this is equal to 1 by twice I 1 by x minus 1 minus 1 by x plus I, x minus I minus 1 by x plus I, Suppose this is number 1. Now differentiate 1 n minus 1 times, because we have differentiated already differentiated y 1 times. We have got y1. To get yn, we have to differentiate y1 n minus 1 times. Now differentiating 1 n minus 1 times, we get ym this is equal to 1 by twice I. Now differentiate this n minus 1 times. If you differentiate 1 by x n times, then the result is minus 1 whole to the power n factorial n divided by x to the power n plus 1. If you differentiate 1 by x or 1 by x plus a n minus 1 times, you will definitely get minus 1 whole to the power n minus 1 factorial n minus 1 divided by x or x plus a whole to the power n. You will definitely get minus 1 whole to the power n minus 1 factorial n minus 1 divided by x minus I whole to the power n minus, for this also, whole to the power n minus 1 factorial n minus 1 x plus I whole to the power n. You will definitely get this. Now ym this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I 1 by x minus I whole to the power n minus 1 by x plus I whole to the power n. You will get this. Suppose this is number 2. Now for x equal to 0, from 2 we get y and 0. Y and 0. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I. You will get here 1 by minus I whole to the power n minus 1 by I to the power n. You will definitely get this one. Or this means y and 0, this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I. From here you will get I to the power n common. Therefore you will get I to the power n plus 1. Already I is here. Therefore 1 by minus 1 whole to the power n minus 1. You will get this one. You will get this one. Suppose this is number 3. Suppose this is number 3. Now we shall discuss the 3 conditions. When n is of the form twice p, when n is of the form twice p 4p plus 1, and when n is of the form 4p plus 3. Suppose we discuss. Suppose case 1. When n is of the form twice p, n is of the form twice p, then minus 1 whole to the power n, here it is minus 1 whole to the power n, minus 1 whole to the power twice p, this is equal to minus 1 whole square whole to the power p, this is equal to 1 to the power p equal to 1. Minus 1 whole to the power n is equal to 1. Minus 1 whole to the power n minus 1. This is equal to minus 1 whole to the power n into minus 1 whole to the power minus 1. This is equal to 1 into minus 1. This is equal to minus 1. You will get minus 1. Minus 1 whole to the power n minus 1. This is equal to minus 1. Now, I to the power n plus 1. Also, I to the power n plus 1. In this case, this is equal to I to the power twice p plus 1. I to the power twice p plus 1. This term will not be required. I to the power twice p plus 1. Just keep it as I to the power twice p plus 1. Therefore 3 implies y and 0 equal to minus 1 whole to the power n minus 1. For minus 1 whole to the power n minus 1, you have got minus 1 factorial n minus 1 divided by twice I to the power twice p plus 1. Minus 1 whole to the power n, it is equal to 1 minus 1. This is equal to 0. This is equal to 0. When n is of the form twice p, then y and 0, this is equal to 0. Case 1 has been proved. Case 1 has been proved. Now case 2. See case 2. When n is of the form 4p plus 1. When n is of the form 4p plus 1, then minus 1 whole to the power m. This is equal to minus 1 whole to the power 4p plus 1. This is equal to minus 1 whole to the power 4. This whole to the power p. Minus 1 whole to the power 1. 1 into minus 1. This is equal to minus 1. Minus 1 whole to the power n minus 1. This is equal to minus of minus 1 whole to the power n. This is equal to minus of minus 1. this is equal to plus 1. Also, I to the power n plus 1, this is equal to I to the power 4p plus 1 plus 1. This is equal to I to the power 4 whole to the power p I square. This is equal to 1 to the power p minus 1. This is equal to minus 1. I to the power n plus 1. This is equal to minus 1. I to the power n plus 1 equal to minus 1. Therefore, 3 from 3 you will get. Therefore, from 3 you will get 3 implies y and 0. This is equal to minus 1 whole to the power n minus 1. You have got it. 1 into factorial n minus 1. 2 times of I to the power n plus 1 is minus 1. 1 by minus 1 whole to the power n is minus 1. Minus 1. This is equal to factorial n minus 1 divided by 2 into minus 1. Here it is minus 2. This is equal to n minus 1. Factorial n minus 1. This is equal to factorial n minus 1. Therefore, y and 0, this is equal to factorial n minus 1. When n is of the form 4p plus 1. When n is of the form 4p plus 1. Now, let us discuss the third condition. Case 3. Case 3. When n is of the form 4p plus 3. When n is of the form 4p plus 3. Let us discuss this case. When n is of the form 4p plus 3. In this case, then minus 1 whole to the power n. This is equal to minus 1 whole to the power 4p plus 3. 4p plus 3. This is equal to minus 1 whole to the power 4. This whole to the power p. Minus 1 whole cube. 1 into minus 1. This is equal to minus 1. Minus 1 whole to the power n minus 1. This is equal to minus 1 whole to the power n. Minus 1 whole to the power minus 1. This is equal to minus 1 whole to the power n divided by minus 1. This is equal to minus 1 divided by minus 1 equal to 1. I to the power n plus 1. This is equal to I to the power 4p plus 3 plus 1. This is equal to I to the power 4p plus 4. This is equal to I to the power 4 whole to the power p, I to the power 4. 1 to the power p into 1 equal to 1. You will get this one. Therefore, 3 implies. From 3 you will get y and 0. This is equal to, you see, minus 1 whole to the power n minus 1 is equal to 1. Factorial n minus 1 divided by 2. I to the power n plus 1 is also 1. Also, this is also 1. Minus 1 whole to the power n is equal to minus 1. 1 by minus 1. Minus 1. This is equal to factorial n minus 1 divided by 2 into minus 2. This is equal to minus factorial n minus 1. This is equal to minus factorial n minus 1. Thus, you have seen that for x is equal to 0, the nth differentiation of tan inverse x is 0 when n is of the form twice p. When n is of the form twice p. Twice p means when you differentiate 2 times, when you differentiate 4 times, when you differentiate 6 times, when you differentiate 8 times, like that. Also, it is of the form, if it is of the form 4p plus 1, this means if you put p equal to 1, 2, 3 like that, then you will get, it is of the form 4p plus 1, then you will get the nth differentiation for x is equal to 0 is factorial n minus 1. And when n is of the form 4p plus 3, then the result will be minus factorial n minus 1. Perhaps you understand this. Let us take another problem. Let us take another problem. Problem number 3. Similar problem. Find the nth differentiation of. Find the nth differential coefficient of differential coefficient of 1 by 1 plus x square plus x cube. 1 plus x square plus x cube. This is first part. We have to find the nth differentiation of this. This is the first part. And the second part is M Ch Deka. So that for x is equal to 0, each value is, so that value is 0 when n is of the form, when n is of the form 4p plus 2 or 4p plus 3. 4p plus 3. If for so that for x is equal to 0, its value is 0, means the nth differentiation is 0 if n is of the form 4p plus 2 or 4p plus 3. If n is of the form 4p plus 2, then if it is yn, then yn 0 equal to 0. If it is of the form 4p plus 3, then also yn 0, this is equal to 0. And is so when n is of the form, and its value will be factorial n or minus factorial n according as n is of the form 4p or 4p plus 1. 4p or 4p plus 1. Now see, we have to find the 4 conditions. 4p or 4p plus 1. Find the nth differential coefficient of 1 by 1 plus x square plus x cube. This is the first part. The second part is we have to find the nth differentiation when x is equal to 0. For x is equal to 0. Next, we are to discuss the 4 conditions. 4p plus, when n is of the form 4p plus 2, when n is of the form 4p plus 3, then we have to show that yn 0, this is equal to 0. Also, when n is of the form 4p, then yn 0, this is equal to factorial n. And when n is of the form 4p plus 1, then yn 0, this is equal to minus factorial n. We have to show it. So this, let us try to solve this problem. Let y this is equal to 1 by 1 plus x square plus x cube. 1 plus x square plus x cube. X cube. This is equal to 1 by 1 plus x square into 1 plus x. This means y this is equal to 1 by x plus 1 into 1 plus x square or x square plus 1. You may write like this. Or y equal to 1 by x plus 1, it will be x plus I into x minus I. It will be like this. X plus 1, x plus I into x minus I. Suppose this is number 1. This is number 1. Now let 1 by x plus 1, x plus I into x minus I. What will be this? This is equal to a by x plus 1. We are going to result into partial fraction x minus I. Suppose this is number 2. This means 1, this is equal to a into x plus I x minus I plus b into x plus 1 x minus I plus c into x plus 1 into x plus I. Suppose this is number 3. Suppose this is number 3. Now put x is equal to 1. Put x is equal to 1 in 3. Left side 1, it will be 1. This is equal to, if you put 1, x is equal to minus 1. X is equal to minus 1. Put x is equal to minus 1. X is equal to minus 1. This term will be equal to 0 and this term will be equal to 0. X is equal to minus 1, then you will get a into minus 1 plus I minus 1 minus I. This is equal to a minus 1 whole square minus I square. You will get this. This is equal to a 1 plus 1. This is equal to twice a. From this you will get a equal to 1 by 2. A, this is equal to 1 by 2. Now put x is equal to I in 3. X is equal to I in 3. If you put x is equal to I, this term will be equal to 0. This term will be equal to 0. 1, this is equal to. This term will be equal to 0. This term will be equal to 0. C into I plus 1 into twice I. Into twice I. This means C, this is equal to 1 by twice I into 1 plus I. Twice I into 1 plus I. And this is equal to minus I square. For 1 you may write minus I square. Twice I. 1 minus I. And in the denominator also you put 1 minus I. You will get this one. This is equal to minus I 1 minus I divided by 2 into 1 plus 1. 2 into 1 plus 1. This is equal to I square means 1 by 4. You will get 1 by 4. From denominator you will get 1 by 4. Minus I plus I square means minus I minus 1. Minus 1 minus I. You will get minus 1 minus I. This is equal to minus 1 by 4 into 1 plus I. Minus 1 by 4 into 1 plus I. You will get this one. Now, you will get this one. Now put x is equal to minus I in 3. You will get 1. This is equal to minus I. If you put minus I, this term will be equal to 0 and the last term will be equal to 0. B into 1 minus I into minus twice I. Into minus twice I. This means B, this is equal to minus 1 divided by twice I. 1 minus I. You will get this one. This implies B, this is equal to I square divided by twice I. 1 plus I. 1 square minus I square. This is equal to I 1 plus I twice 2 into another 1 plus 1, 2 into 2. This is equal to 1 by 4 minus 1 plus I, minus 1 plus I, or you may write minus 1 by 4 into 1 minus I. You may write like this also. Now from 1 and 2 we get, substitute the values of A, B and C. In 2 you will get this is equal to this. From 1, why this is equal to this? 1 by x plus 1, x plus I, x minus I. Therefore from 1 and 2 we get, 1 and 2 we get. Why this is equal to? A means 1 by 2 into 1 by x plus 1. For B, minus 1 by 1 minus I divided by 4. I divided by 4. 1 by x plus I. For C, minus 1 plus I by 4. 1 by x minus I. You will get this one. Substitute the values of A, B and C. We have got the partial fraction. We have dissolved into partial fractions. Now we can differentiate this n times easily. Now suppose this is number 4. Now differentiating 4 n times we get. Now differentiating 4 n times we get. N times we get. Why n? This is equal to 1 by 2. What will be the differentiation of this? N times. Minus 1 whole to the power n factorial n x plus 1 whole to the power n plus 1. Am I right? Next, minus 1 minus I divided by 4. Minus 1 whole to the power n factorial n divided by x plus I whole to the power n plus 1. Minus 1 plus I divided by 4. Minus 1 whole to the power n factorial n divided by x minus I whole to the power n plus 1. You will get this one. You get this one. Now minus 1 whole to the power n factorial n can be taken common. This means yn. This is equal to minus 1 whole to the power n factorial n. It is common. In the bracket you will get half into 1 by x plus 1 whole to the power n plus 1 minus 1 minus I divided by 4. 1 by x plus I whole to the power n plus 1 minus 1 plus I divided by 4 into 1 by x minus I whole to the power n plus 1. You will get this one. Right? This is the answer of the first part. Find the nth differential coefficient of this. This is the first part, answer of the first part. You have got this one. Suppose this is number 5. Suppose this is number 5. This is the answer of the first part. Now for x is equal to 0. Now for x is equal to 0. For x is equal to 0. Y and 0. This is equal to minus 1 whole to the power n factorial n. If you put x is equal to 0 here, you will get 1 by 2 simply minus 1 minus I divided by 4, 1 by I to the power n plus 1. You will get this minus 1 plus I divided by 4, 1 by minus I whole to the power n plus 1. You will get this one. You will get this one. Now, you will go y and 0, this is equal to this. Y and 0, this is equal to this. Now, you may write like this also. Y and 0, this is equal to minus 1 whole to the power n, factorial n, 1 by 2 minus 1 minus I divided by 4 into I to the power n plus 1. I minus 1 plus I divided by 4 into I to the power n plus 1 into I to the power n plus 1 into minus 1 whole to the power n plus 1. You may write like this. Suppose this is number 6. Suppose this is number 6. Suppose this is number 6. Y and 0. For x is equal to 0, we have found y and 0. Now we discuss the different conditions. The value is 0 when is of the form 4p plus 2, 4p plus 3. Case 1. Now we discuss the different cases. Different cases. Different cases. Case 1. When n is of the form 4p plus 2. When n is of the form 4p plus 2. When is of the form 4p plus 2, then you see minus 1 whole to the power n. This is equal to minus 1 whole to the power 4p plus 2. This is equal to minus 1 whole to the power 4 whole to the power p minus 1 whole square. 1 into 1. This is equal to 1. Minus 1 whole to the power n plus 1. This is equal to minus 1 whole to the power n into minus 1. 1 into minus 1. This is equal to minus 1. Also, I to the power n plus 1. I to the power n plus 1. This is equal to I to the power 4p plus 3. This is equal to I to the power 4 whole to the power p I cube 1 to the power p into minus I. This is equal to minus. It will be minus. I to the power minus I n plus 1 is equal to minus. Therefore 6 implies. Therefore from 6 you will get y and 0. This is equal to minus 1 whole to the power n is equal to 1. 1 into factorial n. 1 into factorial n. Half minus 1 minus I divided by 4 into, this is minus I. This is equal to minus I. Minus 1 plus I divided by 4 into minus I. Not only that, minus 1 whole to the power n plus 1 is also minus 1. Minus 1. This is equal to factorial n. and you will get I square minus plus. You may write here plus 1 minus I divided by 4i. For the time being, write like this, plus minus 1 plus I divided by 4i. You write like this for the time being. Then factorial n 1 by 2 plus 1 by 4 minus 1 minus I minus 1 minus I minus 1 by 4 1 minus I. You may write like this. Since 1 by I, this is equal to minus I square divided by I, this is equal to minus I. Since this, now this means yn 0. This is equal to factorial n 1 by 2 minus 1 by 4 minus I by 4 minus 1 by 4 plus I by 4 minus I by 4 plus I by 4 cancel. Minus 1 by 4 minus 1 by 4 means 1 minus 1 by 2 plus 1 by 2 minus 1 by 2. This is equal to 0. And into 0, this is equal to 0. Thus, when n is of the form 4p plus 2, we have got yn 0, this is equal to 0. One part has been proved. Now, we shall discuss the second case. First case has been proved. Second case, case 2. Case 2. When n is of the form 4p plus 3. 4p plus 3. In this case, minus 1 whole to the power n. Then minus 1 whole to the power n. This is equal to minus 1 whole to the power 4p plus 3. Minus 1 whole to the power 4 whole to the power p. Minus 1 whole cube. This is equal to 1 into minus 1. This is equal to minus 1. In this case, you will get minus 1. Minus 1 whole to the power n plus 1. Minus 1 whole to the power n into minus 1. For minus 1 whole to the power n, you have got minus 1 into minus 1. This is equal to plus 1. Minus 1 whole to the power n plus 1, you have got plus 1. Now, I to the power n plus 1. Also, I to the power n plus 1. I to the power n plus 1. This is equal to I to the power 4p plus 3 plus 1. I to the power 4p, I to the power 4. This is equal to I to the power 4 whole to the power p, I to the power 4. 1 to the power p into 1. This is equal to 1. This is equal to 1. Therefore, 6, from 6 you will get. Therefore, from 6 you will get. 6 implies yn 0. This is equal to minus 1 whole to the power n. This is equal to minus 1. You write minus 1. Factorial n. 1 by 2 minus 1 minus I divided by 4 into, it is 1. Minus 1 plus I divided by 4 into, it is again 1. Minus 1 whole to the power, it is also 1. It is also 1. This is equal to minus factorial n half minus 1 by 4 plus I by 4 minus 1 by minus 1 by 4 plus I by 4. Yes, minus 1 by 4. 1 by 4 minus I by 4. It is right, right? No. We are going on the right path. 1 by 2 minus I minus 1 divided by 4 into 1 minus 1 plus I divided by 4 into 1. This is also 1. This is also 1. You see, I by 4 minus I by 4 is cancelled. I by 4 minus I by 4 cancelled. Minus 1 by 4 minus 1 by 4 minus 1 by 2. This is equal to 0. This is equal to 0. This is equal to minus factorial n into 0. This is equal to 0. For when n is of the form 4p plus 3, then also yn 0, this is equal to 0. Then also yn 0, this is equal to 0. We have discussed so far two cases. Now we are going to discuss the third case. When n is of the form 4p, then in this case the result should be equal to factorial n. Let us see. Let us see. Case 3. Let us see the third case. Case 3. Case 3. When n is of the form 4p, when n is of the form 4p, then minus 1 whole to the power n, this is equal to minus 1 whole to the power 4p, minus 1 whole to the power 4 whole to the power p, 1 to the power p, this is equal to 1, minus 1 whole to the power n plus 1, this is equal to minus 1 whole to the power n into minus 1, 1 into minus 1, this is equal to minus 1. Also, I to the power n plus 1. Also, I to the power n plus 1 equal to I to the power 4p plus 1. 4p plus 1. I to the power 4 whole to the power p into I. This is equal to 1 to the power p. This is equal to I. This is simply I. Therefore, from 6 we get. Therefore, 6 implies yn 0. This is equal to minus 1 whole to the power 1 is 1 factorial n 1 by 2 minus 1 minus I divided by 4. It is I. Minus 1 plus I divided by 4. I. Also minus, this is equal to minus 1. This is equal to factorial n half minus 1 by I minus 1. 1 by I minus I by I minus. This is plus 1 by it must be 4. 1 by 4. 1 by 4. 1 plus 1 by I. You will get this one. You will get this one. This is equal to factorial n half minus 1 by 4 minus I minus 1 plus 1 by 4 1 minus I. This is equal to factorial n 1 by 2 plus I by 4 plus 1 by 4 plus again 1 by 4 minus I by 4. You see here, plus I by 4 minus I by 4 cancel. 1 by 2 plus 1 by 4 plus 1 by 4, this is equal to 1. This is equal to, this means, I am writing here, this means yn 0. This is equal to factorial n into 1. This is equal to factorial n. You see, when n is of the form 4p, then yn 0, this is equal to factorial n. Then yn 0, this is equal to factorial n. Now, case 4, last case, case 4. We have to discuss the case 4. Case 4. case 4. When n is of the form, when n is of the form 4p plus 1, then minus 1 whole to the power n, this is equal to minus 1 whole to the power 4p plus 1. It will be minus 1 whole to the power 4 whole to the power p minus 1 whole to the power 1. 1 to the power p minus 1. This is equal to minus 1. Minus 1 whole to the power n plus 1. This is equal to minus 1 whole to the power n into minus 1. This is equal to minus 1 into minus 1. This is equal to 1 plus 1. This is equal to plus 1. Now, also, I to the power n plus 1. This is equal to I to the power 4p plus 1 plus 1. This is equal to I to the power 4 whole to the power p into I square. This is equal to 1 to the power p into minus 1. This time, I to the power n plus 1 is equal to minus 1. Now, therefore, 6 implies, from 6 we will get y and 0, this is equal to minus 1 whole to the power n, this time it is equal to minus 1. Factorial n, half minus 1 minus I divided by 4, it is minus 1. Minus 1 plus I divided by 4, it is minus 1. Also, minus 1 whole to the power n plus 1 is plus 1. This is equal to minus factorial n. It is 1 by 2 plus 1 by 4 minus I by 4. I by 4 plus 1 by 4 plus I by 4. These two terms will be cancelled. This is equal to minus factorial n into 1. This is equal to minus factorial n. When n is of the form 4p plus 1, the result is minus factorial n. You see, all the conditions have been discussed and have been proved also. Now, we shall solve some more problems. Now, let us take another problem of a different type. If this is today's problem number 4. If y this is equal to x square e to the power x, then prove that y and this is equal to half of n into n minus 1 d2y dx square minus n into n minus 2 dy ddx of y plus 1 by 2 n minus 1 into n minus 2y. Now we have to show this. Y this is equal to x square e to the power x. We have to show that y and in terms of the two second derivatives of y, also the first derivatives and y in terms of this, we have to show that. Very easy. Let us try to solve this problem. Solution. Y this is equal to x square e to the power x. Suppose this is number 1. We have to find yn, means nth differentiation of x square e to the power x. Now we differentiate 1 by applying Leibniz theorem. Now differentiating 1 n times. Differentiating 1 n times. By Leibniz theorem we get yn, this is equal to the nth differentiation of e to the power x is e to the power x. N minus 1th differentiation of e to the power x is again e to the power x. Therefore, you will get x square e to the power x plus nc1 differentiation of this twice x, again it is e to the power x, plus nc2 into 2 e to the power x. You will get this one. The nth differentiation is this. Or you may write like this. Yn, this is equal to x square e to the power x plus twice nx e to the power x plus n into n minus 1 e to the power x. N into n minus 1 e to the power x. If your question is like that, if y is equal to x square into e to the power x, find yn, then this is the answer. You may write like this, but you are to prove that yn this is equal to in terms of the 2y dx square like this, in terms of this. Now this means from this you will get yn this is equal to, for x square e to the power x you may write here y, you may write here y, plus twice n x e to the power x plus n into n minus 1 e to the power x. Suppose this is number 2. Suppose this is number 2. Now differentiating 1 times. Now differentiating 1. With respect to x, we get one time, once, only once, with respect to x, only once, only one time we get, only one time, once, you may write only one time we get, only once or only one time. y1 equal to x square e to the power x, x square e to the power x plus twice x into e to the power x, you may write like this, or y1 this is equal to x square e to the power x means you may write y twice x e to the power x by 1. By 1 you may write y in place of x square e to the power x. X e to the power x, this is equal to y1 minus y divided by 2. You may write y1 minus y divided by 2. X e to the power x, you may write y1 minus y divided by 2. Now suppose this is number 3 and this is number 4. This is number 4. Now differentiating 3 again with respect to x. Now differentiating 3 again. Again with respect to x, we get differentiating 3 again with respect to x, we get y2 this is equal to y1 plus 2 times of x e to the power x plus e to the power x. You may write like this, or y2 this is equal to y1 2 times of for x e to the power x, you may write y1 minus y divided by 2 plus e to the power x plus e to the power x. Using 4 you may write like this, or y2, this is equal to y1 plus y1 minus y plus 2 times of e to the power x. 2 times of e to the power x. Or e to the power x or e to the power x. This is equal to y2 minus y1 plus y divided by 2. E to the power x equal to y2 minus twice y1 plus y divided by 2. Suppose this is number 5. Suppose this is number 5. Now, substitute the value of x e to the power x from 4 into and e to the power x from 5 into. Now substituting the values of you may write twice x e to the power x and e to the power x from 4 and 5 into we get from 4 and 5 into we get 4 and 5 into we get y and this is equal to y plus m times of twice x e to the power x y1 minus y, you may write y1 minus y plus n into n minus 1 e to the power x means you may write y2 minus twice y1 plus y, you may write like this. Now y1, first write the coefficient of y2. What will be this? Half of n into n minus 1 y2, n into n minus 1 y2, half of n into n minus 1 y2. Next, write the coefficient of y1 plus, from here you will get n, simply n, y1. From here 2 will be cancelled, minus n into n minus 1, minus 2 will be cancelled, minus y1 n into n minus 1, it will be y1 plus coefficient of y 1 minus n from this plus half of n into n minus 1 into y, you will get this one. Or yn, this is equal to half into n minus 1 y2 plus, take n common, 1 minus m. If you take n common, 1 minus n plus 1 minus n plus 1 y1. From here 1 by 2 common, you will get n into n minus 1 minus 2 times of n into n minus 1 minus 2 times of n minus 1. 2 times of n minus 1. You may write like this. Why? N minus 1. Am I right? Now, this means yn This is equal to half into n into n minus 1 y2 plus n 2 minus n y1 plus 1 by 2 n minus 1 common n minus 2 y. This means yn, this is equal to half into n minus 1 y2 minus n into n minus 2 y1 plus half into n minus 1 into n minus 2 y. Or yn, this is equal to, you may write n into n minus 1, it is nothing but d2y dx square minus n times of n minus 2 dy dx plus half into minus n times of n into n minus 2 dy dx plus half into n minus 1 n minus 2 times of y. You see here, therefore the problem has been solved. It has been proved. It has been proved. Perhaps you understand this. Let us take another problem. Problem number 5. Today's problem number 5. Let us take another problem. Problem number 5. Prove that d to the power n, the nth differentiation of log x by x, nth differentiation of log x by x, this is equal to minus 1 whole to the power n factorial n divided by x to the power n plus 1 log x minus 1 minus 1 by 2 minus 1 by 3 minus 1 by n. We have to prove this. Log x by x, this is equal to minus 1 whole to the power n factorial n divided by x to the power n plus 1 divided by x to the power n plus 1 log x minus 1, this one. Let us try to prove this. Prove the solution. Suppose let y equal to log x by x. This is equal to x to the power minus 1 log x. You may write in this equation x to the power minus 1 log x. Now, suppose this is number 1. Differentiating 1 n times by applying Leibniz theorem. Differentiating 1 n times by Leibniz theorem. Differentiating 1 n times by Leibniz theorem, we get yn, this is equal to x to the power minus 1, the nth differentiation of these, minus 1 whole to the power n factorial n divided by x to the power n plus 1. It is log x plus mc1 n minus 1 times differentiation. It will be minus 1 whole to the power n minus 1 factorial n minus 1 divided by x to the power n minus 1 times differentiation of this into first differentiation of log x only for one time. It will be 1 by x plus nc2 Now differentiation, say x to the power minus 1 n minus 2 times, you will get minus 1 whole to the power n minus 2 factorial n minus 2 divided by x to the power n minus 1. Differentiate 1 by x minus 1 by x square. It will be minus 1 by x square. It will be minus 1 into 1 by x square. Minus 1 into 1 by x square. Plus I am writing more terms so that you can understand it easily. Plus MC3 minus 1 whole to the power n minus 3 factorial n minus 3 divided by x to the power n minus 2. Now differentiate 1 by x. This another one time. Minus 1 into minus 2. Minus 1 into minus 2. 1 by x cube. You will get this one. 1 by x cube. Plus. Now finally, we shall write two terms. The term just before the last term. NC n minus 1. NC n minus 1. NC n minus 1. What will be the last term? We are to differentiate log x. What is the last term? We are to differentiate log x n times. And 1 by x, we will not differentiate it. We are to, in the last term, we are to multiply the nth differentiation of log x by 1 by x. We are to multiply nth differentiation of log x by 1 by x. Now, the term just before the last term, what will be this? We are to differentiate log x n minus 1 times. N minus 1 times. And 1 by x 1 time. 1 by x 1 time. If you differentiate 1 by x 1 time, then you will get minus 1 by x square. Minus 1 by x square. Differentiate log x n minus 1 times. What will be the n minus 1 times log x? What will be the differentiation of n minus 1 times log x? Minus 1 whole to the power n minus 2 factorial n minus 2 divided by x to the power n minus 1. It will be this. Plus, what will be the last term? NCn 1 by x into the nth differentiation of log x. This is equal to x to the power n. Perhaps I am correct. You understand this. Now, from this term, we will get, this means yn, this is equal to, yn, this is equal to, minus 1 whole to the power n, factorial n, divided by x to the power n plus 1 log x, plus n into, you will get here n, minus 1 whole to the power n into minus 1. For this term, I am writing this. And NC1, this is equal to n. I am writing here n into factorial n minus 1 divided by x to the power n plus 1. X to the power n into x to the power n plus 1 plus n into n minus 1 divided by 2. n into n minus 1 divided by 2. I am writing this term first, n minus 2 factorial. Factorial n minus 1. Next, minus 1 whole to the power n into minus 1 whole to the power minus 2. Again minus 1 is there. Again minus 1 is there. Divided by x to the power n minus 2 plus 2. Next term, I am writing this. N into n minus 1, n minus 2 divided by factorial 3. Divided by factorial 3. N minus 3. I am writing this one. Here, minus 1 whole to the power n into minus 1 whole to the power 3 into minus 1 whole square into 1 into 2 divided by x to the power n minus 2 plus 3. You will get this one for this term. And last but one term is what is this? This is equal to n. This is equal to n. N into factorial n minus 2. N into factorial n minus 2. Here x to the power 2 plus n minus 1. It will be minus 1 whole to the power n, minus 1 whole to the power minus 2. Another minus 1 is there. Am I right? This one. Plus, last term is minus 1 whole to the power n, minus 1 whole to the power minus 1. Factorial n minus 1 divided by x to the power 1 plus n. All the terms have been written. All the terms have been written. Now, we are going to write the next term, next line. What will be the next step? You will see. This means yn. This is equal to. This is equal to. First, you see one thing. Minus 1 whole to the power n divided by x. I am going to write another term. X to the power n plus 1 log x. First term is this. What will be this term? N into factorial n minus 1 is nothing but factorial n. This is minus 1 minus 1 whole to the power n factorial n divided by x to the power n plus 1, simply this one. From this, what will be this? It is again factorial n. Again you will get minus. This is minus 1. Minus 1 whole to the power n. From this you will get factorial n. You will get factorial n. Minus 1 whole to the power n. Minus 1 whole to the power minus 2 is plus 1. Minus 1. We have written a minus sign here. Divided by 2. 2. X to the power n minus 1 plus 2 is x to the power n plus 1. Plus. Here also, you see, minus 1 whole square is equal to plus 1. Minus 1 whole cube is equal to minus 1. That minus 1 has been written here. Here you see minus 1 whole to the power n, right? Minus 1 whole to the power n. What is this? This is nothing but factorial n. This is nothing but factorial n. Divided by, here 1 into 2 divided by factorial 3 is equal to 3 only. 3 only. X to the power n plus 1 plus dot dot dot. Last term, last but one term. You see, here also minus 1. also minus 1, minus, right, n into n minus 1 into n minus 2 factorial divided factorial n minus 2 divided by n minus 1. Just multiply numerator and denominator by n minus 1. You will get x to the power n plus 1. Here you will get minus 1 whole to the power n. Minus 1, this is equal to 1. Just all the terms have been written here. And the last term is minus, again minus. Minus 1 whole to the power minus 1, minus. Minus 1 whole to the power n. N into factorial n minus 1 divided by n into x to the power n plus 1. You may write like this. Multiply numerator and denominator by n. And in the last step we have multiplied numerator and denominator by n. And the last but one time we have written numerator and denominator by n minus 1. Now this means you will get here this means yn. I should write here. I should write here. Now write here. Yn, this is equal to minus 1 whole to the power n factorial n divided by x to the power n plus 1 log x. N plus 1 log x minus minus 1 whole to the power n factorial n divided by x to the power n plus 1 minus minus 1 whole to the power n factorial n divided by 2 into x to the power n plus 1 minus minus 1 whole to the power n factorial n 3 into x to the power n plus 1 minus dot dot dot. Definitely all terms will be minus. Last but one term. You see, what is this? This is again factorial n. Factorial n. Minus 1 whole to the power n divided by n minus 1 into x to the power n plus 1 minus, what is this? N into n minus 1. It will be again factorial n. Minus 1 whole to the power n factorial n divided by n into x to the power n plus 1. X to the power n plus 1. Now take minus 1. Take minus 1 whole to the power n factorial n divided by x to the power n plus 1. Take this common. Then you will get, from the first term you will get log x. From the second term you will get 1. From the third term you will get 1 by 2. From the fourth term, like that. And last but one term, 1 by n minus 1. Minus 1 by n. What is this? This is nothing but d to the power n dx to the power n. Log x divided by x. This is equal to log x divided by x. Log x divided by x. Perhaps you understand this. In the lecture number 5, I solved the equation which is, if y equal to x cube log x, then find yn. Then we got the answer minus 1 whole to the power n minus 1. We got the answer minus 1 whole to the power n minus 1 factorial n divided by x to the power n minus 3. In the bracket we got 1 by n minus 3 by n minus 1 plus 3 by n minus 2 minus 1 by n minus 3. But some students are calling me and they told that the answer should have been 6 minus 1 whole to the power n factorial n minus 4. Only that should be answer. I am going to tell you that what actually happens. What actually happened in lecture 5 of analytic differentiation, we solve a question why this is equal to x cube log x, then yn this is equal to, we got minus 1 whole to the power n minus 1 factorial n divided by x to the power n minus 3, we got like this, 3 by n minus 1 plus 3 by n minus 2 minus 1 by n minus 3. In lecture 5, we solve a question, y equal to x cube log x. If y equal to x cube log x, yn this is equal to, we got this result. Some students are calling me that sir, the answer should have been yn equal to 6 minus 1 whole to the power n factorial n minus 4 x to the power 3 minus n. They are calling me that the answer should have been yn equal to 6 minus 1 whole to the power n minus 4 factorial x to the power 3 minus n. They are something, they are saying that something must be wrong in this question. No, there is, we were going on the right path, and we told you that this can be simplified also. Later, okay, I want to tell you that this result is equivalent to this result. I am going to prove you that this result is equivalent to this result. We got that in lecture 5. We got if y equal to x cube log x, then yn this is equal to minus 1 whole to the power n minus 1 factorial n divided by x to the power n minus 3. We got this 1 by n minus 3 by n minus 1 plus 3 by n minus 2 minus 1 by n minus 3. We got this. The students are saying that the answer should have been minus 1 whole to the power n factorial n minus 4 x to the power 3 minus n. They are saying that this term is correct. Other terms are not correct. They are telling, but as a honor student, this is very easy. This can be derived from this. This answer can be derived from this also. Now we got in lecture 5, we got this one. Now you see here, it can be written as minus 1 whole to the power minus 1 factorial n divided by x to the power n minus 3. Suppose 1 by this one. We got this one. This is equal to minus 1 whole to the power n factorial n minus 4 you may write here n factorial n minus 4. If you write factorial n minus 4, then you have to multiply here n minus 3 divided by r. You have to multiply here this divided by r. Minus 3 n minus 1, n minus 2, n minus 3 divided by n minus 1 plus 3 n into n minus 1, n minus 2, n minus 3 divided by n minus 2 plus minus 1 divided by 1 means n into n minus 1, n minus 2, n minus 3, n minus 3, n minus 3. Now let us see. This is equal to minus 1 whole to the power n factorial n minus 4 x to the power n minus 3. This will be n minus 1, n minus 2, n minus 3 minus 3 times of n minus 2, n minus 3 plus 3 times of n minus 1, n minus 3 minus n times of n minus 1, n minus 2. N times of n minus 1, n minus 2. You may write like this. Now see. Minus 1 whole to the power n minus 4 factorial divided by x to the power n minus 3. What is this? N minus 1 into n square minus 5n plus 6 minus thrice n square minus 5n plus 6 plus thrice n square minus 4n plus 3 minus n square minus thrice n plus 2. Minus 1 whole to the power n factorial n minus 4 divided by x to the power n minus 3. Here you see n cube. From here there will be 6 terms. N cube terms is there. Minus 5n square, minus n square, minus 6n square. We have written 2 terms. Total 3 terms have been written. Now 5n plus 5n plus 6n plus 11n. 5 terms and finally minus 6. Here also minus thrice n cube plus 15n square minus 18n plus thrice n cube minus 12n square plus 9n plus 9n minus n cube plus thrice n square minus twice n. Minus twice n. You see here now. Plus n cube minus n cube cancel, minus thrice n cube plus thrice n cube cancel. Now n square terms, minus 6n square plus 15n square. What is this? Plus 9n square minus 12n square minus thrice n square plus thrice n square. All terms involving n square will be cancelled. 11n minus 18n. What is this? Minus 7n plus 9n plus twice n minus twice n. All the terms containing n will also be cancelled. What is left? Only minus 6. You see, only minus 6. This is equal to minus 6 into minus 1 whole to the power n factorial n minus 4 x to the power 3 minus n. This is equal to 6 times of minus 1 whole to the power n factorial n minus 4 x to the power 3 minus n. Now you see this result. From one result you can derive the other result. Therefore our result was absolutely correct. Our result was also absolutely correct. I want to stop here, dear students. We shall meet in the next class. Thanks for attending the class. Thank you very much.